Okay, guys, we're going to continue our discussion of absolute value. Right now, what we're going to do is we're going to cover graphing. Okay, so we're going to start by graphing our parent functions. So our parent function is f of x equal to the absolute value of x. Okay, so I'm going to be very boring, and first I'm going to run a t-chart. So -3, -2, -1, 0, 1, 2, and 3. Okay, I'm not going to bore you with plugging in the numbers. You guys know that absolute value will take a negative and make it positive, so you guys know that. So what I will do is I will just fill out our t-chart. And then we're going to draw a graph. Okay. All right, so the first thing I'm going to do is I'm going to graph the points. Okay, so -3, 3, -2, -2, or +2, excuse me, -1, 1, 0, 0, 1, 1, 2, 2, 3, 3. Okay, so I'm going to connect the dots, but I'm also going to extend them so we can see a complete graph. All right. Okay, so the first thing that I notice is it's in the shape of a V. Okay. All right, the second thing that I notice is that the apex of the V occurs at 0, 0. Well, it's not really an apex because it's not a high point. So we're going to call it the vertex. Okay. I also notice that it has a negative slope. On the left-hand side of 0. And it has a positive slope okay, on the right-hand side of 0. Now, another word for negative slope and positive slope, hopefully you guys are aware, are decreasing. The graph is decreasing. And for positive slope, we can say the graph is increasing. All right, my vertex also has to be the location of my minimum point. Now remember, minimum points are always a y value. So my minimum point is y equals 0. Okay, so that is my parent function. This graph has symmetry. Like that. Okay, so there's a lot going on here, even though it's just a simple v. So what we're going to do now is we're going to do a transformation. We're going to do a very basic transformation. We're just going to flip him over and see how that changes the graph. Okay. So the next graph we're going to do, okay, is going to be f of x equals the negative of the absolute value of x. Okay, so I'm going to be very boring and I'm going to do another t-chart. I'm going to use the same points. Okay, so if I take the absolute value of -3, it's +3, but then I have a negative on the outside, which tells me to do the opposite. So all right, so let's go ahead and graph that, see what that looks like. How many of you think you already know what it's going to look like? Let's see if you're right. First thing I'm going to do is I'm going to connect the dots or graph my dots. And then I'm going to connect. Okay, so if I think about the graph that we just did, the actual parent graph, let's think about this graph. How did it change? Well, the vertex is in the same spot. But now, instead of being a minimum, now it's a maximum. Okay. On the left-hand side, it's has a positive slope. Or it is increasing. And on the right-hand side, now it has a negative slope. Or decreasing. Okay, it still has symmetry. Okay. Now, the really kind of awesome thing about the absolute value function is it kind of follows vertex form of a parabola very closely. So if you're comfortable with graphing a parabola, you should be comfortable graphing an absolute value. Okay, so let's take a look. All right, so let's say I wanted to graph 2x minus 3 squared minus 5. Okay, so you guys would probably tell me, well, there's a vertical stretch. Then you probably might tell me that my vertex would move right 3, down 5, and would be located at the point 3, -5. You guys also might go on and tell me that there's an axis of symmetry. At x equals 3. You might also tell me that there's a minimum value of y equals -5. Okay, well, let's graph it. So just so you know, while I'm graphing, I am going to tell you this. These little videos that I'm making are going to be kind of organic. So if you hear my dog, if you hear my phone go off, that kind of thing, yeah, we're not going to edit those out. All right, here we go. So write 3 down 5. Vertical stretch of 2. And there you go. There's your parabola. Okay. All right. Now, what I'm going to do before we close out, okay, is I'm going to take the same transformations, but now we're going to do it with an absolute value function. Okay. So exact same thing, but with an absolute value function. Now, remember, absolute value functions look like V's. So the sides of them are perfectly straight lines. You're not going to curve. That's the most important thing. Okay. So f of x, 2x minus 3 minus 5. Okay, so this guy, you'd probably tell me that there's a vertical stretch of 2, but you can think about it as a slope. Okay, it opens up. So it's going to look like a V. So you're going to have a negative slope on the left-hand side and a positive slope on your right-hand side. You might also tell me that my vertex moves right 3, down 5, and will be located at the point 3, -5. You'll tell me it has a minimum at y equals -5. You'll tell me it has an axis of symmetry at x equals 3. Okay, let's graph. Also, guys, if you want to look at the notes without the video commentary, you can totally do that. This is available on your Google Classroom. It's on the class notebook. So it's at the very top of the classwork tab. Okay. All right, here we go. See how am I counting out my slope 2 over 1? Positive on the right, and then negative on the left. Okay. Okay, so there's just 2 examples of graphing. So we'll do more, but I'll probably upload those at a later time. All right, see you soon.